So hello everyone, this is lecture 38 for the quantum mechanics. So today we will see the questions based on harmonic oscillator. In the last lecture we have discussed the complete thing about the harmonic oscillator. In the last lecture we were discussing about the Compton effect, and I already gave you the questions based on the Compton effect. So first we will see the questions for the Compton effect, then we will see the question on the harmonic oscillator. So let's see. I gave you this question. Does delta lambda depends on the wavelength of the incident radiation? So not. It doesn't depend on the incident wavelength, because you can see in the formula here, this delta lambda is depending on the only on the Compton wavelength, that is h upon MEC, and that is independent of the incident wavelength, and depending on the only on the deflection angle. So it is not depending on the incident angle. So you will say that it is independent of incident radiation wavelength. Next is, can we observe Compton shift with the visible light? So we can't observe that because lambda of visible light is too large, and there will be very small change, so it will be not noticeable the change. And also this because of large lambda, energy will be very small, and because of less energy, it won't be able to knock out the electron from the atom cell. So there will be no Compton effect here. So that's why this is the answer. So next question I gave you was this. So this was these questions were these. So X-ray and lambda was given are scattered from a target. So find wavelength of the X-ray scattered at the theta 45. So you will use the direct formula I gave you. So what we derived was this. So we'll use directly this formula, and we will find the delta lambda initial and the so incident is given. You can find the reflected one. Similarly, find the maximum lambda present in the scattered X-rays. So maximum lambda is nothing but means this delta lambda must be 2 lambda c. So maximum will be lambda plus 2 lambda c. So lambda incident plus 2 lambda c. This will be the maximum change. So you can find that also. Now find the maximum kinetic energy of the recoil electron. So kinetic energy is simply what means this here the photon is coming and it is knocking out the electron. So whatever energy is remaining will go there. So this change in the energy will equal to the imparted kinetic energy to the electron. So this energy difference will give you the kinetic energy. So next question was it was means simply is this question was also simple, but here they asked about the recoil angle. So now to find the recoil angle, we need to find a relation between theta and the phi. So for that let me give you this derivation to you. Now here we have the photon, here we have electron. After the collision, elastic collision, they will go, electron will go this side and photon will go this side. This is the theta and this is the recoil angle phi. So let's find a relation. So first we will see the x-axis and the y-axis momentum. We will conserve that. So for the x-axis we will see that photon momentum is p and electron has 0. So p plus 0 equal to p e dash, that is for the electron, cos phi going this side, and for the this one it is p dash cos theta. So this is the x-axis momentum conservation. And now for the y-axis, there is no y-axis initially. So after final it is this one equal to this one. So this one is nothing but p e dash sine phi equal to p dash sine theta. So this will be this equation. Now just here this p dash cos phi equal to p minus this. So make these two equations like this. Now divide this equation 1 by this equation. You will get tan phi equal to p dash sine theta, p dash cos theta minus p. Take the p dash common, you will get this relation. And now you have this relation in place of p. We know p is nothing but h nu by lambda. So it will give you nu by nu dash. So you have a relation between phi and theta, which is depending on the incident and the reflected frequency of the photon. So now you have the relation, and you have this relation already, this late delta lambda equal to this. So using these two relations, you can find any coordinates or any variables which is asked. Means other ones will be given, you can find the other ones, the remaining ones. So in this they ask you first delta lambda. So you will use the direct formula. Means the energy difference will give you the energy imparted to the electron. So that's how you can find the kinetic energy, means the energy difference. And for the delta lambda, you know delta lambda is simply this lambda c 1 minus cos theta. And delta lambda when means here you don't need to use this formula because you don't know theta. So you will use the direct this formula. Means incident energy was this and the reflected energy was this. So difference, and then the difference of energy will give you the delta lambda very easily. You can use this one. Means delta lambda equal to sc by e dash. This is nothing but lambda dash minus lambda. So lambda dash will be greater than lambda. That's why this difference will give you delta lambda. So you can write in terms of energy also. Just substitute the value of energy which is given, and you will find the delta lambda. Then if you have delta lambda, then just put in this equation. You can find the theta also. And when you find the theta, and you already know the mu dash and mu, so just put theta mu dash mu, you will find the phi. And the kinetic energy will be difference of these two energies, will give you the energy imparted to the electron. Next question can be done the similarly as we did here. So next question is, using energy and momentum conservation so that a free electron can't absorb all the energy of the photon. So we need to prove that a photon can't be completely absorbed by the electron. So to prove that, let's assume that electron absorb the complete photon, means the free electron absorb the complete photon. So photon is coming and it is absorbed by the electron. Then what happens? So we'll just put the momentum law first. So initial momentum is P, and this was PE for the electron equal to PE dash. After the absorption, it will have some energy, it is moving. So this PE is 0 because initially electron is at rest. So this PE dash equal to nothing but P, that is h nu by C. So remember, this is the equation 1. Now we'll use a conservation of energy. That is for the first photon and electron. So for photon it is h nu by C. H nu plus this rest mass energy of electron, m naught c square, this is the initial energy. And the final energy is electron is moving, only electron is moving. So that electron will have the P dash, PE dash square C square plus m naught square C4. So this is the condition. Now substitute the value of PE dash, that is h nu by C, inside this, and you will get this equation. Now these terms will cancel out and you will get this equal to 0. So this is not possible because this means that there is no photon and the photon's energy is 0. So because after assuming that electron is completely, means photon is completely absorbed by the electron, we are getting this kind of result, which is not possible. That's why we'll say that photon can't be completely absorbed by the electron, by the free electron. Okay, so that's how you can prove this using the conservation of energy and the momentum law. Next is, a photon holds energy equal to the rest mass energy of electron, undergoes a Compton collision with an electron. If the electron moves of an at an angle of 40 degree with the original photon direction, what is the energy of the scattered photon? So phi is given this time, and what else is given? That energy of the photon equal to rest mass energy of electron. So we will use this the things which is given to us. So h equal to m naught c square, this is given, and phi is given. So what we'll find, mu we have, phi we have. So what we'll do, we'll use this equation. In this equation we'll put the value of phi, and we'll put the equation of mu, that is from here, and then we'll have the equation in terms of the theta and the mu dash. Now similarly we have delta lambda equal to lambda c1 minus cos theta. So here we will use again means we know mu, and mu dash is variable again, so we'll use this equation. And theta and mu dash means we'll again get an equation in terms of the theta and mu dash, and one equation from here. So two variable here and two variable here, and we have two equations, so we can solve that to find the remaining terms, that is theta and the mu dash. So that's how you can solve this. This is a simple binomial equation, two variable equation you can say. Now next is, prove that maximum kinetic energy can be possible is only this. So in the last lecture there was no divide sign, so this was a mistake. So here is this divide sign, this is in the denominator. So I already told you that what is the maximum kinetic energy. Kinetic energy is simply what is the difference between the energy of the incident photon and the reflected photon. So that difference will be equal to the kinetic energy. So to make it maximum, we know this is kinetic energy, this minus this. Now to make this maximum, this should be minimum, and this will be minimum when the maximum change in the wavelength will be there, means maximum energy loss. So for that, lambda dash should be maximum. So lambda dash can be maximum equal to lambda plus 2 lambda c. So this is the maximum difference. That's why lambda dash must be equal to lambda plus 2 lambda c. Now we have this kind of thing. Now we need to just solve this and we'll get our answer. So we'll substitute the value of lambda c, and we'll solve this, and we'll substitute for the lambda equal to h upon p, and p is nothing but h nu by lambda. So this is simply this, means sc by lambda. You can just simply c equal to nu lambda, so lambda will cancel out, it will be nu here, and again c equal to, means you just need to substitute for the lambda, c equal to nu lambda, use that, and lambda will be c by nu, so that will be c square by nu. So when you solve this, you will get your answer. Now you can write this in this form also. So this is the incident radiation energy. So you can write it also in the terms of E, that is E 2E, and you can write it 2E square by mc square. So now in the next question they asked us, find the energy of an X-ray photon which can impart a maximum energy of 50 kilo electron volt to an electron. So we need to find this. So maximum energy is 50 kilo electron volt. So just to write it in terms of the Kmax, and we need to find the energy of the X-ray photon. So find this E value and you will get your answer. So this is this E is nothing but h nu. So h nu, this is 2E square, this will cancel out, you will get mc square here plus 2E. Solve for E and you will get your answer. Now next we will consider the questions for the harmonic oscillator. So this is the most important thing. We will discuss all kind of questions can be asked in the harmonic oscillator. So they can ask you the expectation value to find this x for x square, for x cube, for x4 or for p square, p cube, p4. So if we try to solve them by the manual, means the basic method, so that will be a very long page, means long solution. So what we do, we will use this kind of notation which we already described, these operators, that is a. So x is under root h cut by 2m omega a dagger plus a, and p was this. So we already discussed this. So if you need to find the expression value of x or the position in any particular eigenstate, so you know how to find this. This is n, xn. So that's how you do it. So just put in place of x, that is this term. So this will be outside and this is a dagger plus a. So again, we will just solve this n, a dagger n, and n, a, n. So that's how you will divide this. Now we know what these operators are. This is a raising operator and this is a lowering operator. So you can see here, when this a will operate, it will change to n minus 1 and it will be under root n. And when a dagger operates on n, it will give you under root n plus 1, n plus 1. So this an will give you under root n minus 1, and this will give you under root n plus 1, n plus 1. Now we know this is nothing but, this is a Kronecker delta function, means when there are same states, that will be 1. When they are different state, that will be 0. So this is again become this. Now this will always remain 0. That's why we will get for the x, in any particular state, if you will find the expression value of x, that will always be 0. So you must remember this. Similarly, for if you find for p, that will also give you 0. If you solve like this, using this, you will get 0. So if we try to find for the x square, this will be a very long calculation. So we just you need to remember some trick here. So what tricks are there? Whenever there is x to the power m and you need to find the expression value, so for all odd values, for x to the power odd values, this will always be 0. Like for x equal to 1, means m equal to 1, this will be 0. So we already proved this. For x3 also this will be 0. For 5 also this will be 0. So for whatever m is, when m is odd, this will be 0. And when m is even, so that will won't be 0. So we just need to remember these two for x square and x4 here. So for x square, this will be equal to h cut by 2m omega 2n plus 1. So for the 0th state, you will get h cut by 2m omega. For the 2, you will get 2 to the 4 plus 5 by 2 h cut divided by m omega. So that's how you will solve this. Or the first state you will get 3 by 2, and that's how you will solve for different state. For m equal to 2, means for x square, expression value of x square will be like this. And for the x4, expression value will be in this formula. So just substitute the value of n and you will get the expression value of x, means x4. So remember, for the odd values this will be 0, and for the even values, for x square this will be this, for x4 this will be this, for different states of n. Okay, for different n states. Now similarly, we will get the same formula for p also. So pmn means when m is odd, so you will get 0 always. When m is even, so you again get for p square, this will be your formula for different state, and just substitute the value of a state here, you will get the expression value of p square. For p4 also, just substitute the value of n and you will get the expression value of p4. This is 6n square plus 6n plus 3 m omega h cut by 2 whole square. So you just need to remember these formulas. We will see the question based on them. And next is, now you know if you need to find the expression value of energy, means the eigenvalues of energy, so that will be n plus half h cut omega. But what if there is some perturbation in the potential or the Hamiltonian? So what is the meaning of perturbation? We will study in detail. But here the perturbation means that there is some change in the potential. Means there is some addition of some factor of potential inside this Hamiltonian, that will give you the perturbation. Perturbation means some disturbance. So if this is your Hamiltonian, then simply this will be your energy eigenvalue. And in case of perturbation, this kind of potential is added, like plus lambda x. Now what happens? The first order correction and the second order correction. So we need to get the correct value of energy. So for the correct value of energy, the first order correction will give you, simply this will give you 0, and you will get the same value as you are getting in this. So first order correction won't give you any change. This will remain same, n plus half h cut omega. But for the exact value, you need to do the second order correction. And what does that mean? This is the formula, coefficient of x and square of that 4 multiply coefficient of x square. So coefficient of x is nothing but lambda. So lambda square divided by 4 multiply coefficient of x square, that is this half m omega square. So you will get this. So this is your energy eigenvalues now. So this is the exact result, means only you need to do the correction up to the second order. So these are your energy eigenvalues. So Question can be asked based on this perturbation also. So you must remember only this formula for the harmonic oscillator. So, and they can ask you what is del x del p, that is the uncertainty also. So uncertainty is simply under root x square, x and this. So we know this formula for this, and the average of x, this will be 0. And so it will be simply x square average of this and under root. And this is also again the same value. So we know x square average, that is this one. This one h squared by 2 omega 2 n plus 1. So it will be under root of this. So that's how you will get delta x, and that's how you will get delta p. And if you find the del x delta p, so that will give you h squared by 2 2n plus 1. So that is again the following the uncertainty principle. That is, this must be greater than or equal to h squared by 2, and this will be greater than that, because n equal to 0 1 2 3 4 will give you greater than this value. So now you must remember these formulas, that first write the Hamiltonian, and then find the eigenstates, eigenvalues, and then write the time independent wave function in terms of c1 phi1 c2 phi2, then find the time dependent wave function. So that's how you will write. So let's see the questions now. The state vector of a 1D harmonic oscillator is given: 1 phi naught minus 1 phi 1 minus 1 phi 2. So where phi naught, phi 1, phi 2 are the orthogonal eigenstate, we need to find the exponential value of energy. So that is simply E naught P naught plus E1 P1 E2 PE2. So this is your expression value of energy. You already know this is probability of E naught. So we know eigenvalues E naught, that is h squared omega by 2, E1 is 3 by 2 h squared omega. So what is the probability? Probability can be find it from here. The coefficient C1 phi 1 C2 phi 2 C3 phi 3. So from there, probability is simply C1 square divided by C1 square plus C2 square plus C3 square. And for probability for second one, this one, it will be C2 square divided by C2 C1 C2 C3. And again for this one, again it will be C3 square divided by C1 square plus C2 square plus C3 square. So do you know now, you know the formula for the probability, so we'll use the same formula, and it will be 1 upon 3 for this probability for this first state will be 1 upon 3, because coordinate is 1 square divided by 1 square plus 1 square plus 1 square, this will be 1 upon 3. For the second one, it will be 1 square by again 3, 1 upon 3, 1 upon 3. So you will get your expression value, that is 3 by 2 h squared omega. Next question is again, it is same. So it is second state, is third state. So we need to find the exponential value of energy. So it will be same procedure. E naught P means E2, PE2, E3, PE3. Next is time independent wave function is given. This is U naught U1. And at t equal to 0, we will find the exponential value of E. You need to prove that you will get this answer. So find the exponential value of energy first. Then at any time, the exponential value of energy will remain same what it was at 0 time. So you must remember this thing always. Then you need to find the time dependent wave function. So you will use this formula. So this will be your answer. So first find the means time dependent wave function you need to find. So you will get this one. So try to solve. So you will get these as your answers. Next question is, initial wave function is given 1 upon root 2, 0 and 2. These are your states. And you need to find the time dependent wave function. This is time independent. So this is your answer. So you can use the same formula again, which we used in the last. So next question is the minimum time t after which the vector this is orthogonal to this. So orthogonal condition is simply when the dot product will give you 0 or the inner product will give you 0. So just take the complex conjugate of this one, and this cat will change to bra, and this will give you 0. So just substitute this value and find the value of t. Answer will be pi by 2 omega. So try to solve. This will be very easy. Now in the next question, they ask you the minimum time t after which the oscillator will be found in the same state. So at time t, in the same state means inner product should be equal to 1. So this square must be equal to 1. So try to solve this. Find side means this one. So just to take the dot product of this with this, means complex conjugate of this, and take the dot product with this and put equal to 1. Find the value of t. Next question is, psi is given 1 upon root 2, and this is your 0 state, first state, and this is your second state. And you need to find the delta p, that is answer is under root m omega h cut. So how will we find? So there is this formula. We know delta p. So delta p for the 0th state, what will the formula? That will be m omega h cut by 2. Means from here you can see that we already write it for the p square. That was m omega h cut by 2. So for the 0, it will be only m omega h cut by 2. And for the 1, it will be 3 by 2 m omega h cut. So now we have exponential value of p square for 0 and the 1. And now what we need to do is, we just need to multiply the probability to find the overall expression value. So probability will be simply This square divided by sum is already 1 upon root 2 square. 1 upon root 2 square will give you 1, so probability will be 1 upon root 2 square, and for this also 1 upon root 2 square, so that will be 1 upon 2 for the first one, and 1 upon 2 multiplied for the this one. This will give you the overall p square, and we know delta p is simply under root p square average, so that will be p square is this, so under root m omega h squared will give you the answer. Now next question is, this wave function is given, find t after which the oscillator will be found in the same state. So again, find a time dependent wave function and take the inner product, put equal to 1, and find the t, of course. Next is, potential is given half m omega square minus ax, and so what we need to find is energy eigenvalue. So again, for the second order correction perturbation, use the formula. It will be square of the coefficient, means after this n plus half h squared omega, square of the coefficient, that is a square, divided by 4 multiply this value, coefficient of x square, that is half m omega square, that will give you 2m omega square. So these are your eigenvalues of energy. Now there was this question asked, h was given p square by 2m, half m omega square x square plus lambda x. So what is the difference between the energy states of the first two levels? To find the energy difference, you need to find the energy eigenvalues first. To find the energy eigenvalues, you know there is this perturbation term, so you need to use this formula which we already derived. So n plus half h squared omega minus coefficient of x square, that is lambda square, divided by 4 multiply the coefficient of x square, that is half m omega square, will give you 2m omega square. So this is your energy eigenvalues. Now for the first state, it will be n equal to 0, h squared by 2 minus this. For the first, it will be 3 by 2 h squared omega minus this. So next state minus this previous state will give you again h squared omega, because this is a constant term, this will cancel out. Now there is this question, the psi is given c0 0 and c1 1, and c0 square plus c1 square equal to 1. So for what value of c0, the exponent value of x is maximum. Also find the maximum x. So this question is similar as this one. So we need to prove that this will equal to b1 equal to b2, or here c0 equal to c1. So how we'll do that? So for that, we need to solve this in this way. We need to solve the exponent value of x. Here we find that for the separate eigenstate, we were getting exponent value of x as 0. But for the combined state, we won't get it 0. Means here we get it 0. But for the combined state, like for the 1 and 2, the wave function is combining 0 and 1 state. So that won't give us 0. So again, in place of n, we need to write the wave function now. So how we'll solve? So let's see the solution. So this is your x, that is psi x psi. So psi is given c0 0 and c1 1, and so this is the cat. So bra will be c0 star 0 and c1 star 1. So x is under root h squared by 2m omega a dagger plus a. Substitute the x value here, and this psi and psi means cat and bra both. So here, now these are your all terms. So what you need to do is, you just need to multiply them. So first multiply this one with this one with this, then this one this one this. Then whatever you will get, multiply this with these terms. So you know how to write this in the notation. So we'll write them accordingly. Now what will happen? We know this is a raising operator, and when a dagger will operate with 0, it will give you under root n plus 1 n plus 1. So it will be 1, and here it will be 1. So you will get this kind of thing. 1 and 1 square will give you c0 square is already there, and under root 1 will be 1. So that won't be make any difference. Again, when a will operate on the 0, that will give you under root n minus 1. So under root n will be 0, so that will be 0. So this won't be here, this will be completely destroyed. And here when a operate with 1, this will give you again, means under root n will give you 1 here, and 1 minus 1 will give you 0. So it will be there, c0 c1 0 0. So that's how we'll use just that raising operator and the lowering operator. So we'll get this kind of terms. And here you know these all are orthogonal, 0 1 1 2. So this will give you 0, this will give you 0, but this won't give you 0. This will be 0, and this will be 0. So only two terms will be remaining, c0 c1 and c0 c1. So this star won't make any difference because these are not imaginary. So c0 c1 will be equal to c0 c1, c0 star c1. So it will be 2 c0 c1. Now we need to minimize this. So there is one more condition is given, c0 square plus c1 square equal to 1. So c0 square equal to 1 minus c, means c1 square equal to 1 minus c0 square. Substitute this value here in place of c1, and you will get some function in terms of c0 square. So f c0 equal to some function is given. So you know how to maximize the function, that take the derivative of that function and put equal to 0. So there you will find the value at c0 equal to 1 upon root 2. You will get the maximum value of that function. So that will be very easy to solve if you know the differentiation. So that's it. And when you find a c0 equal to 1 upon root 2, substitute it here, and you will get c1 is again also 1 upon root 2. So you'll find that c0 equal to c1 when it is maximum. So that's how you already solve this question also, this one where they say that b1 equal to b2. Now try to solve these questions by yourself. In the next lecture, I will give solution for these also. Del x del p equal to h squared by 2 for n equal to 0. So del x del p is what for when it is phi l equal to exponential minus iota p l divided by h squared 0. So this is given. You need to find this for this. If the RMS momentum of a particle in the ground state of 1D harmonic oscillator is p naught, then find RMS momentum in the first excited state. A particle is in n equal to 0 of one dimension harmonic oscillator potential. An impulsive force at t equal to 0 suddenly impart a momentum p naught, that is under root h cut m omega. Find the probability that the particle remain in the original ground state. Vx equal to half m omega x square, x is greater than 0, infinity when x is less than 0. Phi naught x is given minus 1 upon root 5 phi naught plus 2 by root 5 phi 1. Find exponential value at t equal to 0 and find wave function at means time dependent wave function you need to find. For a 1D harmonic oscillator, the A dagger acting on the nth state, that is where n equals 0, 1, 2, 3, 4, that will be this, under root n plus 1, psi n plus 1, and x is given under root h cut by 2 omega A plus A dagger. So, what you need to do is find the matrix representation of x for 3 into 3 matrix. So, try to solve them. In the next lecture, we will see the solutions. So, thank you everyone.